guys, welcome back. This is Abhishek and welcome to my YouTube channel. So today in this video we're gonna discuss about a web client for visualization pandas object. So what web client is? This is a library. By using you can do all kind of EDA. You can handle missing values, you can describe column, you can plot chart, and without just you just don't need to code anything for plotting. You don't need to code anything for handling missing values. You don't need to code for predicting for prediction power. You don't need to code for feature selection, feature engineering, and all these things. So detail is really very powerful library, and I will walk you through with each and every feature, and I will show you how this works. I have working on detail for a long time, so that's why I think I'm able to give you a whole explanation of detail. And trust me, this video will be a very most explained video on detail on YouTube. Okay, so let's start. So if you are using detail for the first time, you haven't used yet, so what you have to do, you have to do this. You have to install detail by using pip install detail. Either you can use conda as well. So right now I'm on my Jupyter notebook. So we will do in this whole notebook, we have done pre-processing by using detail. So what pre-processing consists of? In pre-processing we deal with missing values, we remove outliers, we do feature selection, and we do plotting, and we do analyze columns, and at all we learn from them. So first of all, you have to import, and you have to install detail and then import it. So then what I have done here, I have imported my necessary libraries. So as you can see, pandas, numpy, matplotlib, sns. So I really don't need these things, and I'm just importing pandas and numpy right now. And now then I'm reading my csv file, which is trend.csv, and then I'm importing detail, right? Okay, so now very important thing which you have to understand, that whenever we have any kind of data set, any kind of csv, you don't need to split them into x and y. Whatever csv you are having, whatever data frame you converted, that you have to just pass in detail dot show. So just detail dot show, and then you have to pass your data set, you have to pass your data frame, and then you have to um, run this. If you will have already loaded a frame file, if you have already loaded the same data frame, then it will throw an error, and for that you have to pass ignore 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 duplicate as true. So when we do ignore duplicate as true, suppose ran I have run this cell again, and now I'm trying to run it again. So it will show an error. It's showing that our data set has already loaded on detail. You can check out by on this link, or if you want to load it again, you have to pass this flag as ignore duplicate equal to true. So right now I'm doing ignore. I want it to load again, so ignore duplicate as true. So just run this, and just wait until it loaded. And here you can see the data set has loaded. It looks as the same data frame as pandas gives us, but there is different. There is some play button. This is the length of rows, and this is the length of columns. So first thing first, what you have to do, just click on any column name, and then choose any option, but I would suggest choose this describe. Okay, then this as you click on the describe, it will throw you at an another tab, and on that tab what you are able to see, you will have a describe page, and there is a bar where you can see all your features, and their data type is mentioned. For training our model, we need all columns must be int or float. Here is some strings, here is some strings. So how do we deal with those string values? We use label encoder, we use ordinal encoder, and all these things. So, and on the right side you will be able to see describe, word, value count. There's some graph as well. So here total rows and missing values is showing up, and then top rl frequency means the top means this keyword has come mostly. So frequency, with frequency of 1151, unique values, and there is standard deviation and all these things, and then unique values. Okay, so right now what you need not to do anything on this page, so go back to the data and let's start everything from scratch. Okay, suppose you are having a data frame that is not pre-processed at all. That data frame might have missing values. That data frame might have some columns, useless columns you can say, and that data need to be feature selected and all these things. So this is totally raw data, and I will show you how to work on any raw data by using detail. So first thing first, you have to click on this play button. Okay, so we have started to play with our data set. So what you have to do, first thing, you have to go to this low variance flag, if you are able to see this. Okay, so what you have to do, just check this button. Okay, and just slide it, and you will be able to see there is some columns with the flag and red color. So there is a flag and in red in color, and there is few columns as you can see here if I show you whole. Okay, so what does this mean? Okay, so first let me show you what I have clicked. I have clicked low variance flag, and so what low variance flag means, it shows a flag in every column which is not important for our training. So if this is red and with a flag, so it means that this column is not important for our model. And why I am saying this, let's understand. So let's understand what is a low variance column. Suppose this is a column. Okay, and suppose this column has 100 rows. Okay, 100 rows. For safe, let's take 100 rows. Okay, so variance means, in general way, variance means variation, we can say. And we notice 98 rows are same as 0. Okay, only two rows have different values. Okay, only two rows have different values in this column, and all 98 rows has same value. So do you think this column will have any importance in training of our model? So you would think that this column have no importance for our model, because every value is almost 98% values are same. Only 2% values are different, and that 2% value will confuse our model, and that 2% value which are changed will increase the complexity of model. 98% values are same means these 98% values are constant. Okay, so they will not contribute in any kind of prediction, because these values are same for every rows. Okay, that's why it's always better to drop them. So that's why I'm dropping these columns just by clicking on this and click on the delete button and select yes, and you can delete all these columns one by one. Okay, I have just showed you how to do this process. I'm not going to delete every column again, because it's gonna take my time, and I don't want this video to become longer than, that's why I'm not deleting those things. And okay, so after suppose you have in first step you have dropped all those columns with low variance, right? And then second thing what you have to do, then second thing you have to deal with missing values. And for dealing with missing values, what you have to do, just highlight missings. Okay, highlight missings. Okay, so all these columns with yellow in color have missing values. More yellowish shows you that this column have more missing values. If you compare these color with these, so this is much darker, it means this column have more missing values. Okay, and there's few things here. And then if you go furthermore, you will be able to see these columns are much darker. These columns are much darker. So these columns are much darker in yellow, means these columns have more missing values, and you are good to drop them. Okay, just confirm this, how many missing values are there inside. Just click in this and go on describe, and then you will be able to see that 99% are missing values. So do you think we should drop this column? Yes, we should drop this column because 99% missing values, only 3 5 7 non-missing values right here. So I think we have to drop this, and that's why that was much darker. So what we can do, we can delete this column, and these are not that much darker, and that's why I left. And there was one more column, this was much darker, and that's why I'm deleting this. Okay, and now so now we have dropped a few columns which has missing values more than 90%. Okay, now as you can see that this is our numerical column, numerical d type. So we have to fill these missing values. So we can fill these missing values by giving any values, or by using median, by using mean, whatever. But I will always prefer you to use median, because median is more robust to outliers. So if you have any outliers, the median will not change, and that's why we always fill missing values by their median. Okay, let's do this. Just click on that column which you are trying to deal missing values, and then click on replacements, and then in place, and select replacement type value, and search for nan means not any number, means null values. So okay, so if you want to replace with any your given number, any your custom number, you can give anything. Okay, sometimes you may want to change it with 0, so in that case you can use raw. Otherwise you have to use aggregate. What aggregate means, aggregate means it aggregate gives you some method. And right now I will select median, you can select mean or anything, whatever you want. So right now I'm using median, sorry. Let me select median. Okay, then click on this plus button, and this will extract a code. You can simply copy and paste this code on your Jupyter notebook, and this code will perform the same operation which we are doing by using this GUI. Okay, so what you have to do, after when your code appears right here, then you have to just click on replace button. And as you see here, all my missing values has gone. Okay, and now let's move further, and now we are trying to deal our categorical missing values, right? So categorical missing values is really very important. I cannot leave them. Okay, for categorical missing values I'm selecting this column, because I'm not gonna deal every missing values in this data frame, because again this is gonna take so much time. That's why I'm not doing this. Okay, what you have to do, there is a little change whenever you deal with categorical missing values. What you have to do, first describe that column. Okay, so here we did, and then you see that 2.6% missing values, it's good to go, we don't need to drop this. And what you have to do, you have to see uh, you have to see the top means, top is means the value which have maximum frequency, means the value which has most time appeared in that column, and that is what this top saying. So in this column, whenever we will see any missing values, we will simply change with no. Okay, so in BSMT means basement exposure, I think. So in that basement exposure, if you find any missing values, I will simply replace with no because it has maximum frequency, and we hope that missing values will have again the tend to maximum frequency, and that's why we will replace with no. Okay, so let's do this. Replacement, and then value, and then raw. And then what I would do, we don't need to do like this. We don't need to do like this because we are not coding, we are just using a simple GUI. So just select no, and then click on this plus button, and then replace. Okay, so here you are able to see that we haven't any kind of missing values. So this is the way how do we deal with missing values. Now we're gonna tell you something more about it. So this is missing values, we have done missing values, and we can remove outliers as well. So again, outliers, if outliers is, suppose outliers is light red, it means that you don't need to remove that. Okay, you can understand this. Okay, and if it's blue, it means that like uh, okay, just describe any column. I'm just giving you a very simple example. Let's take this value, and so and what you have to do, just click on the describe button, choose describe, and then you will be able to see that I have 24 outliers. And if you apply this outlier, means the rows of having those outliers will be removed, and your data fit will become much shorter, means it will have less 24 rows. So it will drop all those 24 rows, it will just filter out all those rows. Okay, and if you upgrade grid, it means like whatever you have applied, whatever change you have applied, it will upgrade. Okay, so if I'm just upgrade, so here you can see now my all those filters has applied here, and I'm only selecting those outliers. Okay, for now I'm just removing it, and just click on these outliers, and these are outliers. You can even change all those things and all this. So the best way to remove outliers, just click on this and go on the describe, and click on outliers, and just click on apply outlier filter, and you can even see the code. And this is the same as we do in pandas. And okay, now you are able to see that we have just selected all those filters not having outliers. So this is on the same way, but data set become much shorter, and that's why I personally don't prefer you to remove outlier by pandas. Okay, because whenever we have outlier, we can use log transformation, we can do other things, we can tweak all those things to overcome all those outliers. We can use robust scaler and all these things. So that's why it's not always a good practice to remove outliers, but it's always, you have to always deal outliers. You can't just let it go to model, you have to deal outliers, because this is really a nightmare for a data practitioner. Okay, now we have seen how to do with outlier, how to deal with missing values, how to deal with low variance. So this was all about feature selection, because we have just dropped some features which was not important. Okay, now what I have to show you a feature engineering. You can do feature engineering as well, you can build your own columns. So feature engineering means same, you build your own custom columns which have more information by taking some columns which has low information. So in this way you reduced your number of columns, and you collect all those information from various column to a single column. This is all about feature engineering. Okay, so let's do some feature engineering. How would I do that? Just go on build column, and then let me just maximize it, and I'm saying I'm creating a new area, and then column type would be numeric. You can select any of these, and then I want uh, let me show you one thing. Here you can see lot frontage and lot area. Both are just related to some sort of area, and I want to add these two columns. I will add them. I will create a new column and I will drop these two columns. So in this way we can reduce some number of columns. If you have any kind of cursive dimensionality, you can use this technique, but I'm just showing you how we can do feature engineering. But again, it depends what kind of operation you should apply. It depends on your data set. So I'm just showing you how anyone can do that feature engineering by using this. Where has that gone? Okay, let me select that option again. Okay, so what we do, we go to build column. Actually that was new tab, and I think that was already opened. Okay, right here. Okay, I will give a name, and then I will apply an operation of sum, and then I would select lot area, and then I would also select lot frontage. Okay, here we go, and then we will create, and a new column has been added, and I suppose that column must be placed at the last. Let me just show you. Here I have. Okay, so you can do some feature selection by these things. So and I find the best advantage of detail is you can remove your if you are dealing with natural language processing, you can remove stop words, you can remove all those stop words, you can remove any kind of symbol, all these things you can do this. How do we do that? Let me show you. uh, I have an option of custom filter. No, it's not that custom filter. Okay, suppose this column has any kind of, let me show you, this column has any kind of number. uh, Suppose this column has any kind of number, and I can save it as any kind of number. What you have to, you can remove that by using clean column, and here you have to select column name, and you can use, if you have any kind of white space, you can remove this by this. You can remove punctuation, like these symbols and all these. Punctuation means all those symbols and all these things, and you can drop stop words, you can drop nltk stop words, you can remove even number. If I have any string values and with number, you can remove all those things. Okay, so keep alpha means it will be this will be like 1 2 3, and for this will be only string values. Alpha means all alphabets, and normalized accent character, all these things you get options. So I'm not using that, but I showed you how anyone can do that. Okay, and now suppose you want to do some feature selection. That's really very important. By using detail you can do feature selection, but I would not prefer you to do this. I have already uploaded a video on feature selection, and that is, I think that is the best way to do feature selection, because there is various method to do feature selection, and you have to just stick with few methods which always works. Like, and again, feature selection depends on model to model, so that's why you have to select a very robust model which can take your features information correctly. And again, I have, everyone has really a very misconception that you can do feature, we can do feature selection by using uh, correlation graph, linear correlation graph. So that's again a very bad thing. You don't need to do feature selection by using that, because if you do that, you're gonna lose information. Okay, what I'm talking about, I will show you. Suppose this is, I'm selecting the correlation. So here it will show you all mutual correlation, and again, these all are Pearson correlation, means these are linear correlation. these are not showing any kind of exponential, any kind of square relation and quadratic relationship. These are not showing that. These are showing only linear relationship. If lot area increases, then basement fin SF1 increases by 0.21, and these all things are okay. So these all are linear relationship, you have to keep in mind. And you can't do feature selection by using this. Okay, if someone does, then I think it's just to give you an idea what kind of relationship where features are having, but you can do any kind of feature selection by using these correlation matrix. Okay, now if you want to know any kind of feature selection, any kind of relationship between your target and your features, input features, what you have to do, I'm selecting my target column. And now as you can see here, as my id as my sale price and id, it has linear minus relationship, means if id increases sale price decrease, something like that. But that doesn't make any sense, because as we go top to bottom, my id will again increase. So overall quality shows a strong linear relationship. As you can see here, overall quality and sale price shows a linear relationship. And this is your very important feature, because as this is very clear that if your overall quality will increase, your sale price will increase. So in this way you can say. Okay, and all these are year built. As there is linear relationship, as year built increases, means our house is newly built, so sale price will definitely increase. So in this way you can do feature selection. And suppose this has a negative relationship, and here we can select anything, we can't say about anything, because there is no linear relationship. But I'm not sure that it is useless. Okay, suppose this is 0.17, it means it has low linear relationship. But I'm not sure that this is useless column, because it may have any kind of other relationship, any kind of other information. So that's why we don't do any kind of feature selection by correlation matrix. Okay, so this is to give you an idea of, which features are really important, and how they relate to our target column. Now the second thing what I have to do, you can select the back to the data, and you need not to go a new tab. And then very important thing, there is a new thing which is pps is just a score which show you predicting power. Okay, prediction power. If pps is higher, and it means that this column is really much important for your prediction. So let's do that. Again, this pps predictive power score takes a time to load, as it was already mentioned here. And meanwhile I will show you how chart works. Let me close all these tabs. Okay, okay, for now just understand how chart works, and when predictive power score will be loaded, I will tell you how we work with that. Okay, so here we select x. Here I'm selecting x as my sale price. Here I'm selecting sale price, and here you can select lot area. Here you can select so many things. You can select area, which we newly made this column. Okay, and you can select various column for making plot. So right now I'm just selecting one. Okay, just let it go. Okay, so sale price and area, as you see that as area increases somehow, and sale price also increases, you can say something, but it's still not clear. And you can apply aggregation means if you want to count all those, and okay, so you can just sum and then you can plot it, and something like that. You can mean them and then plot it, means the mean as your mean of area and then sale price. It's the graph of your area, mean, and then sale price. So all these things. And let me select a very important year built, because we know that there is a linear relationship. Sale price contain duplicates, please specify. Let me select once again, and scatter. You can see here there is a really linear relationship and all these. You can select various kind of plot here, and you can select bar plot and everything. So here it's showing chart error because sale price have um, some duplicates sale price, because two home may have same price, and that's why it's showing me an error. I can group them, even. Okay, so let me fix it. Okay. mm, just go again in charts, and now I'm selecting my sale price again. Where are you, sale price? I have got you sale price, and then I'm selecting, suppose I'm selecting condition. You will see as condition increases, we can say that house price is increases, but again it's not always true. You can select other land slope as well. And again, if you want to plot this graph to your Jupyter notebook, what you can do, you can code export, and this is all code for plotting this graph. And again, this code will import a plotly, because these interactive graph has made on plotly, as you can see here. So when you export this code, keep in mind that plotly must installed in your PC, in your notebook, in your computer. Okay, so you can handle all these things. So this is all about your chart. You can play around with these values and all these things. So again, now very important thing is, let's come to predictive power score. On predictive power score, what we do, we select our target value, and let me select my target values. Okay, and then our target is sale price, and then you can see sale price versus mass PNR area has low predictive power. Okay, and overall quality has high predictive power as 0.31, and year built 0.14, and year remote at 0.14, all these things. This is high correlation. So keep in mind, what you have to do is you have to focus on model score, and you have to focus on baseline score, and you have to focus on score. Okay, and this model score has given by decision tree regressor, and this model score is given by regression. Okay, linear regression. And there is if there is any linear relationship, and this score will higher than this one, decision tree regressor. This is linear relationship, and that's why baseline score is much higher. So you have to use features whichever will have model score greater than a reasonable. You have to just select all those features which will have a model score, a very I would say a very good model score. I can decide that this is not good model score. You can compare it, and you can select all these. If is valid score, if there is yes, then you can select all those features. And again, let me tell you one thing, this is really again very important. You do feature selection only when you have so many columns. What so many column mean? If you have more than 20 or more than 30 columns, only then you do feature selection. Suppose you have 10 column or 15 columns, then you have no problem. All important feature will be automatically used by our model, and the rest feature which are useless for our model will not affect our model very much, because useless feature will be just 2 or 5 or 10, then those few those features will not affect our model very much. And if you are using any model which has already prone to to our feature selection, there are some many models which automatically do feature selection, like tree based model. They are bootstrapped, they automatically select all important features, and in that case you really don't need to do feature selection. But it's always practice to drop those columns which you are sure that this is not important. So I have already made a video on feature selection on this channel, you can check out those videos. And there's various method for feature selection. just stick just stick to few methods which I have told you. And because feature selection depends on model to model, and that's why you can't decide which features are important and not. And that's why you have to select a very robust model to decide which features are not important for us. And what I think is the best method to do feature selection. You need not to do feature selection by using detail and all these things. What you have to do feature selection, okay, okay, suppose this is model 1, this is model 2, and this is model 3 I made, and these three models have performed well on my data. Okay, suppose this is a random forest regressor, this is suppose XGBoost. Okay, and this is suppose our, let's say, EXT, extra tree class C extra tree regressor. Okay, what we do, we fit our model to these, we fit our data to these models. And then what we do, we do feature importance, we call feature importance for all these models. And what they return, they returns us all those columns name with their importance. And then what we do, we select top no we select all those features which will have minimum importance. Okay, suppose all these models return feature importance, and I have got 20 features which have the lowest importance. Here I got 40 features which have got lowest importance, and here I have got suppose here I have got 60 features which have low importance, means lower importance. Then what we do, we convert all these column name into a set, and then what we do, we take intersection. Okay, and then whatever feature we will get, we will say that these features are useless features. So on this way we do feature importance. This is very well and very verified method, and this all these techniques comes to you by practice. No one will tell you on any kind of medium channel, on any kind of Krishna channel. So you have to just find all these technique on yourself, just how you can and discover all these channel. And these all comes when you practice your data, when you play around your data. So all these come from there. Okay. So I just told you, if you need more explanation on this, you can simply check out my video on this channel. So this is all about detail, and if you have any kind of queries, if you have any kind of problem, you are feel free to ask me on comment section. You can drop your question right there, and I would like to help you as soon as possible. Okay, one more important thing, as you have deal everything in your data set, then what you have to do, go to export, and then click on the CSV, and your imported your pre-processed data will get here. And you can again load in our Jupyter notebook, and you can work on them. And if you have noticed that in detail we can't do label encoding, we can't do label encoding, we can't do ordinal encoding and all these things. So after all, at the end you have to use your pandas skill to do all those things. And you have to use scikit-learn for all those things. So detail will not do everything for you, so just keep in mind. So this is all about detail, and thank you very much for watching this video. Please do share and subscribe this channel. I need your support to grow up, and I upload data science related videos weekly basis, and that's why you have to subscribe. And thank you for watching. Good night, take care.